Swayam Prabha. Digital India. Educated India.
I am Tanish Deshwal
And I am Arsh of class 11th.
of DPS Greater Noida. Hello everyone. Today we are going to show you our everyday science project.
This project consists of two forces that are very crucial in our everyday life, that is the centrifugal and the centripetal force.
Centripetal and centrifugal force both are important, but let us tell you what these forces actually are.
Centripetal force is the force that is directed towards the center of a circle. When a body is in a circular motion, its speed does not change, but its direction changes. This is called as UCM or uniform circular motion. What happens is that a force is directed towards the center, which is an invisible force and changes its direction.
Centrifugal force is a pseudo force which actually does not exist, but it is still there due to centripetal force. We can consider an example when we are driving on a curved path. When we are driving on a curved path, the outward force experienced in the car is the example of centrifugal force.
Now, we will like to show you a project.
So, this is our project, and we can see that there is a ball attached to our project, and there is a heavy bottle. And when we start rotating our hand, the ball will start rotating.
The weight of the ball is negligible in front of the weight of the bottle. Yet, when the ball rotates, the bottle is pulled upwards. The kinetic energy of the ball is converted into potential energy of the bottle. There are many forces that are involved in this experiment, such as
We can see that mg is acting on the bottle and tension in the string. We can also see angular momentum is totally conserved. The ball is still rotating till the bottle comes down. And when we stop our hand, it will start moving faster. So hence we can say that angular momentum is conserved.
Do you know any applications of this project? I am sure you don't. Now let us tell you.
There is a problem of transporting. So we can consider a plank on a steeper side, so we can airlift objects from the bottom of the hill. We can just put it downwards. We can consider it as an object or a big bucket or tanker in which it contains water. And when the ball starts rotating, it comes upward. And by this, we can save time, energy, and work.
Did you understand here? No, I don't think so. Now let me tell you another example. What happens, we can also use this to launch a rocket in the aeronautical fields. What we can do is when we have an hilly terrain, we can create a huge hole to the bottom of the earth and we can suspend a very heavy weight there. Due to it being on a height, the potential energy is conserved in the block. When a rocket is attached to a tensible and strong, very strong string, it starts to rotate when we leave the weight. When it comes down, all of its potential energy that was conserved in the block now gets transferred into the kinetic energy of the rocket. And when the block reaches the ground, its kinetic energy, or as you may very well know, the angular velocity is at its maximum. Then we can detach the rocket from the string. This will cause the rocket to go in a tangential path. At that point of time, no force is being acted on the rocket.
We can also use this in a flood probe areas. Let us consider an example. There is flood going on and it is very difficult to airlift people. When we airlift people, the person sitting inside the helicopter has to pull it so that person comes up. But still, this model can be used in airlifting. As we will rotate this ball, the person will come upwards.
I am sure you may laugh at me for saying this, but this can also be used as in gym equipment. When we increase the weight that is hanging below, the force in our wrist increases and it makes our wrist stronger and more durable.
As we can see, this model has various applications and we can also develop much more applications by time.
Now I'm sure that you have understood this project and I'm sure you will love to see us again.
Thank you.